Hello everyone, greetings from VNR JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and IADS. Today I am going to discuss about the concept of process synchronization in operating system. So process synchronization. Process synchronization in operating system refers to the multiple process or can execute in coordinated manner or cooperative manner. So that means the process or multiple processes are together, they can cooperated and they can coordinated manner without interfering with each other. So the processes can be synchronized together for sharing their resources. So what purpose they are synchronizing together? They are sharing their resources. They want to share their resources. So to do that one, the processes can be synchronized together. So here it is refers to the multiple processes, that may be either one process or two process or three process or whatever it may be. Number of processes, multiple processes, or you can say it as multiple threads. They can execute in coordinated manner, cooperative manner, without interfering with each other, when they share their resources like memory, files or devices. So regarding memory, they can share their memory. Regarding files, they are going to be sharing their files or folders. And regarding the devices, they can share their printing options or device sharing options or any other options. So to access all these resources, the process 1 from the main memory, process 2 from the file management, process 3 from the device management, all these processes can be coordinated together, cooperative together. Without their cooperation, no other resource cannot be accessed by the another process. So to do this access from one process to another process, to sharing their resources from one process to another process, they have to cooperative manner. They have to do in the cooperative manner, or they are to do in the coordinated manner. So this manner or this behavior is nothing but process synchronization. This behavior or this process is called as process synchronization. It is a mechanism in operating system used to manage the execution of multiple processes that access shared resources. So if you want to access the shared memory, they have to cooperate to each other. And the process synchronization is the coordination of multiple cooperating processes in a system to ensure controlled access to shared resources, thereby preventing race conditions and other synchronization problems. So if they are not having the controlled access on the shared resources, they may get the problems like inconsistency of the data and loss of the data and deadlock and starvation or prevention of the data. So the data may be inconsistency and the data may be loss and the data may be in the starvation process. So the process can be cooperative in controlled access way, and the process can be synchronized in controlled access way. They want to access the resources based on the certain restrictions. They want to access the particular resources based on the controlled access options. So there are different types of process synchronization. There are mainly two types of process synchronization. The two primary types of process synchronization in operating system are, first one is what? Competitive process synchronization. And the second one is what? Cooperative process synchronization. So how they are cooperative and how they are competitive. So the two or more processes are said to be competitive synchronization if and only if they compete for the accessibility of shared resources. So when you see in the race conditions of general running race conditions or any bike racing conditions, if the two persons or the two other parties can be competitive in the race, then they can ready to access the accessibility of the shared resources. So here the same thing, the two or more processes are said to be in competitive synchronization if and only if they compete for the accessibility of shared resources. Suppose take an example, if the printer giving the option called as printing for process 1, that is device 1, and process 2, that is device 2. If these devices, these two processes or devices can be competed to access these shared resources. So if one can access, if other one can access one by one. If those two are those two are in the access, those two are accessing the same time, then the data may be inconsistency or deadlock may be occur, the starvation may be occur. So they can be competitive. They can be competitive. And the second one is what? Cooperative. So here competitive, lack of proper synchronization among competitive process may lead to either inconsistency or data loss. So that is what happening. If the same thing for the second one, cooperative process, two or more processes are said to be in cooperative synchronization if and only if they get affected by each other. They get affected by each other. That is, execution of one process affects the other process. The execution of one process can affects the other process. So if you take an example of internet connection, internet connectivity through the router or through the Wi-Fi, if one device can able to access the device, if one device can able to access the particular internet option, then other device is ready to access the internet option. If this router is giving the support to connecting two or more devices, then it is ready to give the option to accessible for all the devices. So they can be cooperative, one to another, one device to another device. If these two are competitive manner, then the one device cannot be allowed to another device, one device access cannot be allowed to another device. So that is the way competitive and cooperative processes are differentiated to each other. So here they can be affected by each other. Execution of one process affect the other process, and lack of proper synchronization among the cooperative process may lead to deadlock. So this is the way competitive and cooperative processes together synchronized together to access the shared resources. If they are not properly competitive, if they are not properly synchronized together, the competition may be the inconsistency of the data loss in between those two processes, or they can be leads to the deadlock also. So what are the conditions that require process synchronization? What exactly the conditions are requiring the process synchronization here? So the conditions that occur process synchronization are, first one is what? Critical section. Critical section. It is a code segment that can be accessed by only one process at a time. So critical section is nothing but it is a code segment process, and that can be accessed by only one process at a time. And when the race condition, it is a situation that may occur inside a critical section. And the third one is what? Preemption. So preemption is when the operating system stops a running process to give the CPU to another process. So it stops and it gives a priority for the another process. It stops running and giving the option to another higher priority of the process. That is the preemption. So what is meant by critical section? So we already said that what it is. A critical section is a code segment that can be accessed by only one process at a time. So critical section is nothing but it is a zone, it is a separate zone which can be accessed one by one, only one process at a time. So one process can allow to access, and after that utilization of that access again gives the chance to another process. So the critical section contains shared variable that needs to be synchronized. So critical section contains what? Shared variable, and that needs to be synchronized to maintain the consistency of the data variable. So it contains shared variable that need to be synchronized to maintain the consistency of the data variables. So the critical section problem means designing a way for cooperative processes to access shared resources without sustaining data inconsistencies. So the solution is what? To give the, it is a way for the critical section giving the solution to design such a way for cooperative process to access the shared resources without creating a data inconsistency. So how we are going to give the solution means that solution will not be affecting for the data inconsistencies. The solution will not be giving the data inconsistency problem. So these critical sections prevent information loss by preventing two processes from simultaneously being the same critical region or updating the same variable simultaneously. So always we have to update the shared variable. Always we have to update the shared variable. So shared variable is in the inside of the critical section, and the critical section allows each and every process at one time. Each and every process at one time. So at that moment, shared variable can be alerting to other process. The process which is inside of the critical section is still accessing the section. If it is over, then we will inform to other process. So like the way shared variable can be informed to all other processes. So here the problem is called the critical section problem. And one of the solution to this problem is Petersol solution. Petersol solution. So that will be discussed in the next sessions. So here the critical section, how it occurs. So the process contain entry section, critical section, existing section, and remainder section. So always the process can allows only one process into the critical section. So entry section we have to give, we have to enter into the section, but to access the particular resources, we have to enter into the critical section. So in the critical section, only one process can enter and utilize the particular resources, and after that it comes to the exit section. So like the way this process synchronization process works here. And here the structure of process with critical section. So how the structure is completed with the process synchronization. So here entry section, critical section, exit section, and remainder section. So how these all sections are working together. So here the first part is what? Entry section. So this part is responsible for requesting permission to enter into the critical section. So the entry section allows to grant the permission to enter into the critical section. So if any process wants to enter into the critical section, it must be grants from the entry section. So this part is responsible for requesting permission to enter into the critical section. And it uses synchronization mechanisms like semaphores, mutex locks, or hardware instructions. All these synchronization mechanisms it uses to ensure that only one process enters into the critical section at a time. So it ensures that always it checks that each and every time only one process should be entered into the critical section, so that they have to check each and every time. So example, acquiring a lock, checking with the semaphore. So acquiring a lock, when you want to apply a lock for particular process, lock for a particular process, it must be ensured that into the critical section. After entering into the critical section, it must be locked. After utilizing that particular resources, then it has to be relieved from this lock. So that is the way entry section allows the process to grant the permission to enter into the critical section. And the main part, critical section, is the main part of the code where the processes access or updates shared resources like files, variables, database, printers, whatever you want to update, whatever you want to do all the database operations on the particular resources, then they are doing all this from the critical section itself. So only one process can execute here at a time. So when the process entered into the critical section, that process can do all the database operations, no doubt at all, but only one process can execute here at a time. So only one process can do all these operations at a time. For example, updating a shared bank account balance. So in the real-time example, if anybody having the bank balance, suppose like 50,000 amount, if anybody is crediting the amount 5,000, then the amount will be 55,000. If anybody is nothing but the person who is having that bank account will be drawing 10,000, then the remaining amount will be 45,000. At this time, all these three operations, credit operation, balance display operation, and debit operation, so all will not be shown at a time. So at that moment, to do this process, it entered into the critical section. After finished, again it has to update. So to do this update process, it has to enter into the section. After do this one, again it has to come to the credit process. So again it has to enter into the critical section and do the process. So only one process can do these all operations by entered into the critical section by accessing the shared memory. So this is the process that they are doing all the operations in the critical section itself only. And third section, exit section. Third section is what? Exit section. So after finishing the critical section process, so what we are doing, what we have done on the critical section, all the updating sections, all the operations, database operations, all the operations whatever we have done in the critical section, after finishing all that in the critical section, the process executes the exit section. Process executes the exit section. So same like in the cinema hall, when you want to enter into the movie theater, you first grant the entrance by showing your ticket, right? You must grant the entrance by showing your ticket. So after showing the entrance ticket, that is entry section, you must enter into the hall. So that is nothing but you are entered into the critical section. Here you can see the film, or you can sleep even yourself, or you can do whatever you want to do, right? So all these operations you are doing in the hall itself, that means in the critical section itself. So after completing this movie, what you are doing, you are exiting from the theater. So exit section will work. So here this is the way the process releases the locks or semaphores so that other process waiting can enter. So once your show is over, the next other show people are waiting for to enter into the hall. So this the way the process exit section works. And last one, reminder section, the part of the code outside the critical section. So whatever the remaining part of the code will be available outside of the critical section is the reminder section. Here the process performs operations that do not involve any shared resources. That code is only for showing the operations but not to perform any operations in the critical section. So synchronization is not needed here. So reminder section, synchronization is not needed here. So if you want to go for another movie, or if you want to go this movie for another time, then you can having the reminder to enter into the critical section. So like this example, local calculations, user inputs, preparing data, all this comes into the reminder section. So like the way the process synchronization works. So all these sections, first one is what? Entry section, to grant the permission to enter into the critical section. And second one is what? Critical section. Here you can do all the operations whatever you want to do. And third one is what? Exit section. This is the section where you can allow to go outside or allow to after finishing your works, your exit section. And last one, reminder section. If you want to do the same thing for again multiple times, then you are taking the reminders for to do these processes. So these are all the process synchronization mechanisms. And any solution to this critical section problem must satisfy three requirements. So if you want to propose any solution to this critical section problem, that must satisfy three requirements. What is that? First one is what? Mutual exclusion. So mutual exclusion. If a process is executing in its critical section, then no other process is allowed to execute in the critical section. That means the two processes together mutually they are processes to understand. Mutually they can be excluded. Mutually they can be executed. So one process can enter into the critical section and the other process is allowed to execute in the critical section. No other process is executed to in the critical section. The progress, second one is what? Progress. If no process is executing in the critical section and other processes are waiting outside the critical section, then only those processes that are not executing in their remaining section can participate in deciding which will enter into the critical section next, and the selection cannot be postponed indefinitely. So if no process is in the critical section, then reminder section will calls the entry section, reminder section calls the entry section, or else reminder section will deciding that who will enter into the critical section. who will enter into the critical section. Next, and the selection cannot be postponed indefinitely. So the critical section is only for mean to enter the process into the critical section to access their resources. If no process entered into the critical section, means the remainder section will reminds there is no process at all, please send some other processes to utilizing the critical section. So what will be in the critical section is decided by this reminder section. And third one is what? Bounded waiting. So a bound must exist on the number of times that other processes are allowed to enter their critical section after a process has made a request to enter into the critical section and before that request is granted. So a bound must be exist on the number of times. So we have to wait, we have to give the waiting, or we have to give the signal operations to allow the process into the critical section or not. So there must be some bounded variables. So the process are allowed to enter into the critical section after a process has made a request. So we have to maintain that boundaries. We have to maintain that boundary variables. So that request variable or response variable or wait variable or signal variable to enter into the critical section. Whatever that boundary variables that we have to maintain. So to prepare any solution, these three conditions must be satisfied. One is what to including the mutual exclusion. Second one is what to show the progress, and third one is what to bounded waiting, creating the boundary variables. So these are all the concept of process synchronization, and what are the sections of process synchronization, and the problems arises through the process synchronization, and the solutions to the critical section problems, what must satisfy three requirements. So more about this content, if you want to see the more content about this topic, you can use the following referral links. So use all the links for getting more data for the process synchronization and the processes. I hope all of you understand. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.